Now, dear student, question number 11 says the figure shows a parallel plate capacitor being charged by a battery. If M and N are the two closed curves, then during the charging, the closed integration of BDL is 0 along the curve. The first M only, second N only, both M and N, and last neither M nor N. Now dear student, let's see, this was a circuit, this was being charged, and we are considering this loop, and along the loop there is magnetic field, right? Then in this case BDL, I'm taking the loop N over the closed path. This is not equal to 0. This is equal to mu naught time the current flowing through this called the conduction current. When you take the loop M, this loop is this one, and here we know that flux as displacement current is passing through this, and again BDL over this closed loop will be equal to mu naught time the current through this one called the displacement current. So this is also not 0 and this is also not 0. So the correct option is the option number 4. Let's move to the next problem. Question number 12 says, which of the following have zero average value in plane electromagnetic wave? Electrical energy, magnetic field, both 1 and 2. Now dear students, whenever electromagnetic wave moves, then you know that the magnetic field has certain equation like that B is equal to B naught and sine cos omega t minus kx, like this one. Now its average value, if you take this is a sine curve, and average value will be equal to 0, and therefore the average value of the magnetic field is 0. So we have one option, third, and let's look at the energy. And when you take the energy you know is proportional to the square of magnetic field, then sine square will come, and its average value won't come equal to be 0, because sine square omega t you get some value 1 by 2. Therefore neither electrical energy nor the magnetic energy will be 0. So only the correct option to this is answer number 3. So let's move to the next problem. The question number 13 says the amplitude of the electric field in a parallel beam of light with the intensity 1.5 watt per meter square. Now dear students, the intensity have the relation the average power multiplied by C. And what was the average power? 1 by 2 epsilon naught E square multiplied by C. And what is given? It's given that intensity is 1.5. So this would be 1 by 2, and epsilon naught is, I'm keeping as this, and E naught square. And see, the velocity of electromagnetic wave is 3 into 10 is power 8. And you know E naught will be what equal to 1.5 into 2 divided by epsilon naught, 3 into 10 is power 8. Right? So what is the amplitude E naught equal to? E naught equal to root of this one. That is 3 divided by epsilon naught, 3 into 10 is power 8. So 3 will cancel with 3, and you have to take it up, and the root it become 10 is power minus 4 divided by a root of epsilon naught. So this should be the value of amplitude. So answer to this question is second option. Let's move to the question number 14, and we read the statement. The question 14 says that if lambda IR stand for infrared, lambda X, that is X rays, and lambda gamma rays represent the wavelength of infrared rays, X rays and gamma rays respectively, then the order of the wavelength is asked. And you know student that the frequency of gamma radiation is more than the frequency of X-rays is more than the frequency of infrared, and wavelength is reversed because all travel the same speed. Therefore the wavelength of infrared ray will be more than the wavelength of X-rays will be more than the wavelength of gamma radiation. And look at the option. The answer to this question is option number 2. The question number 15 says there is a small air bubble inside the glass with a refractive index of 1.5 of radius 10 centimeter. The bubble is 6 centimeter below the surface and viewed normally from just outside of the same surface. The apparent depth of the bubble is. These are the 4 options. So refraction at the curved surface, this was the curved surface. Radius of curvature is given to you. And the radius of curvature of this surface is given. This R is equal to 10 centimeter. Right? This will be the center of curvature. This will be the pole. Now, what is given that the object or bubble is at the distance of 6 centimeter. That means if you look from outside, we are viewing from this side, then your U, because the ray will travel from here to here, the U will be equal to minus 6 centimeter. We have to find the V, and for refraction formula is that mu2 upon V minus mu1 upon U is equal to mu2 minus mu1 divided by R. Mu2 is the medium. From where you are looking, that's air. So that is 1.00 upon V we want to search out minus mu1. Mu1 is from where the ray is coming, and this refractive index is given equal to 1.5. So 1.5, and what is U from here? That is minus 6. By sign convention is equal to mu2 1.00 minus 1.50 divided by radius of curvature, and radius of curvature is equal to minus 10. So this become 1 by V and the sign become plus, and 3 by 12 is equal to 1 by 20. So take on this side that therefore 1 by V become equal to 1 by 20 minus 1 by 4. So if we solve, then V comes to be equal to, take the LCM 20 and 1 minus 5. So therefore V is equal to minus 5 centimeter. And answer to this option is the first option, that the apparent depth of the bubble will be 5 centimeter from this point.